All right, practice problem. So let's go ahead and solve this. Here we are. This basketball is going 3 meters per second to start with, and then it goes backwards at 1 meter per second. It's pretty exciting. Now what's going to happen, we got to describe the motion of the basketball. So let's go ahead and do that now. So for 3 seconds, it goes forward at 3 meters per second. Then back at 1 meter per second for 4 seconds. And now one thing I want to be clear on here is this little vertical line here, that's not a thing. It doesn't mean anything. It's just a way of connecting the top part with the bottom part of the graph. Now let's draw a motion map based on the velocity graph. So I'm going to label my meter stick number line here. And I'm going to give it 2 meter increments like this. So at 0 seconds, I'll start at 0. Now, 1 second later, since I'm going at 3 meters per second, that means I'll be all the way here at 3. Since I'm going at 3 meters per second, and I'll label my time, 0 second, 1 second. After 2 seconds goes by, I've covered another 3 meters because that's my speed. And then finally, at 3 seconds, I wind up at 9 meters, having gone another 3 meters. Then what happens is I go backwards at 1 meter per second. So at 4 seconds, I'm here. 5 seconds, I'm at 7. 6 seconds, I'm at 6. And at 7 seconds, I make it all the way back to 5 meters. How far did the ball travel from 3 to 7 seconds? So when we actually look at that, from 3 I was at 9. At 7 seconds, I'm at 5. So 9 minus 5 is 4 meters. Another way to look at that is I can get the area underneath the velocity graph, and that gives me 1 times 4, which is 4 meters. Finally, if I draw a position versus time graph, so at 0 seconds I'm at 0. At 1 second I'm at 3. And actually, let me label these. So 2 meters, 4 meters, 6 meters. Not quite. 2 meters, 4 meters, 6 meters, and 8 meters. Similarly with my times, 2, 4, 6, and 8, like this. So at 1 second I'm at 3. At 2 seconds I make it to 6, and at 3 seconds I make it to 9 since I'm going at 3 meters per second. And if you actually see the slope here, it'd be 3. Then I go backwards at 1 meter per second. And I wind up at a position of 5 meters. All right, so that's how to do this problem. I'm actually going to do a second video where I take this graph and I use that to draw the motion map if you prefer drawing motion map from your position graphs. And what you can do on the appraisal on Monday is you can go do this part first and then do the motion map at the end.